I want you to look at this question here. Look at this question carefully. So, and let's write down the value that we are given. So first of all, we are given that we need to prepare 1000 mil. This is the volume, by the way. Let me write volume. And then of what? Of we are of AgNO₃, and then its concentration is 0.0800 mole per liter. It's like this. So actually this capital letter M is the same as mole per liter. So capital letter M is the same as mole per liter. It's one and the same thing in this case. So I want you to think of it in this manner. Let's take the volumetric flask. Volumetric flask is something like this. The volumetric flask has a mark somewhere here. It has a mark, the volumetric flask. So I want you to think of something like this. Then obviously it's 1000 mil, the volume of this volumetric flask. Normally this 1000 mil, it will be written on the label here of that volumetric flask. So on the label here, they will have written that it's 1000 mil. It will be written, but let me erase it for now. So what is this? This is concentration. So we are required to prepare this concentration of this compound. So how do we go about it? Let's read the question. Describe how to make up the required solution. How do you make up the required solution? So in order to make up this solution, what we need to find out is to remember this one will be in solid form. So it's more like powder. We will need to find the mass of this compound, AgClO, silver nitrate, AgNO₃. So how do we find that one? We know that molar mass of what? Of AgNO₃, close brackets, is equals to, let's plug the periodic table here. Let's check it out on the periodic table. Check for, this is the periodic table. So check for Ag and check its molar mass of the periodic table. Check the nitrogen one and also check the oxygen one. So you will realize that the masses are going to be 107,874 Ag for this one. This is the mass, right? Then plus for nitrogen, the molar mass for nitrogen is going to be 14,01, right? And we have only one nitrogen here. But for oxygen, we have 3 oxygen. And for oxygen, each mass, or the mass of oxygen, is going to be 16 multiplied by 3. Let me close brackets here, like this. So I multiply by 3 because we have 3 oxygen here. So at the end, the total molar mass will be somewhere around 169,87 gram per mole. Look at it in this manner. You know by now that, let's say, let me write it here. You know that number of mole is equal to CV, right? Number of mole, we just calculated it here. The concentration we know, it's here. The volume we know. But again, number of mole is equal to mass divided by molar mass. This is the capital letter M. So it simply means that if I want to find the mass, I can use this relationship. And now, how do I find number of mole first? let's do this first. Number of moles is equal to CV. What is the concentration? Concentration is this one. It's 0.0800 mole per liter. Multiplied by the volume. The volume is going to be 1 liter because it's 1000 mil. 1000 mil is going to be 1 liter. From there, the number of mole is going to be 0.0800 mole of what? Of AgNO₃. So this will be the number of mole. Now, since we have the number of mole and the molar mass, we can find mass. So from this formula, we can rearrange and find that mass is the same as number of mole multiplied by molar mass, which is going to give us what? The number of mole is 0.0800 mole multiplied by the molar mass. We calculated it here is this one, multiplied by 169.87 gram per mole. Then when you press a calculator, the answer is going to be 13,5896 gram. What does that mean? This simply means that now to answer the question, remember, do not forget what the question was asking us. They want to know how are we going about to prepare this solution. So this simply means that we are going to weigh this amount. Obviously, it will be in powder form, right? Let's assume this is the bottle. If this was the bottle that contained AgNO₃, if this was the bottle that contained AgNO₃, obviously we're going to take the gram, this amount, 13,589896. We're going to take the powder and go to weighing balance and weigh. In other words, we're going to use a weighing balance to weigh this amount of AgNO₃. Once we have that powder is the one that we are going to dissolve it first, meaning that you can just have either beaker or anything that can hold this gram. Then you add it here. Let's assume we add it here, that 13.5 gram of AgNO₃. Let's say we add it here, right? Just for it to dissolve first, right? Even if you add it here directly, there's no problem. However, the best way may be to add it here on the beaker. Then you add water, right? When you add water, you dissolve it. Then after you dissolve it, you can transfer it here nicely. Obviously, when you transfer it here, it will come maybe and be something like this, right? And occupy this space. Remember, it can't fill all the way as it is because it's small. The volume that you have here is small because we just need to dissolve it. Then you will obviously add distilled water all the way to the mark. And obviously, when you add distilled water, you can also make sure that before you reach the final or before your distilled water even reach the final mark here, you can take a little bit of distilled water and wash the remaining. Remember, when you add it here, there may be leftovers here, so you can also wash this and add, and make sure that at the end of the day, nothing is left there on the beaker. However, even if you want to use it here, you are more than welcome to take it on the volumetric flask. Then you dissolve, then you get what you needed.